Hello and welcome. Today we're going to be using SPSS to kind of take a look at our data, see what story our data is telling us, understand exactly what's contained in our data, and also to get information about how we need to make manipulations to our data to really get to the root, the core of the questions that we want to answer. So later on we're going to make manipulations, drop some values, change some values, merge some values, sometimes split things out. So the first step is taking an examination and seeing what we have in there. Now, once again, we're going to be using SPSS 23, but previous versions of SPSS are going to have most of these functions. So most of this will translate to previous editions and hopefully future editions as well. So once again, the agenda we have for today is talking about the basics of descriptive statistics, both univariate statistics, and we will be doing a little bit of what we call crosstabs, which will allow us to look at two variables and kind of compare and contrast them, find out how the frequencies change for a change in the other variable. The first thing we want to do, though, is we want to examine our data set. We're going to be using today the federal sentencing data set from 2006. Now, this is a small cut of the data set, about 72,000 sentences handed down in federal courts in the United States for the year 2006. So this is a small sample. This is only 72,000 of those cases for the entire year. We're going to be using this data set just as an example to kind of play around with a little bit of a sandbox. The major variables we're going to be using today, we'll be kicking around age and a variable of the ordered age, essentially, so it's broken into categories. We will also be using gender of the individuals, so 0 being male, 1 being female. We'll also be using months P, which is the total number of months the individual spent or was sentenced to prison. And we'll also be using some other variables as well, such as education level. Here we have an operationalization of education, less than high school graduate, some college, and college graduate. So once again, this data has been kind of manipulated and curated a little bit just for our example purposes to keep it nice and simple. The first thing we want to do is we want to examine a variable and see what does it say, how is it distributed, what does it look like. So let's start off by examining something fairly simple, such as gender. So we know the mon-sex variable is the gender variable. It's listed as the label as gender. Once again, 0 equaling male, 1 being female. Let's examine how many cases are men and how many cases are women in this data set. So what we want to do is we want to go up here to these menus and we want to click on Analyze. This is almost always where we want to go as a menu selection if we want to examine our data. Now just to the left of it we have the Transform, and we'll use this at a later date to go ahead and cut up, change, and manipulate our variables, create new variables out of multiple variables. But for now we want to use Analyze. So within Analyze, we can go down to Descriptive Statistics, and this gives us a group of tools that will allow us to examine what our data looks like. If we slide over, we have two major options to be starting off with: frequencies and descriptives. They do some of the very similar things. Descriptives will give you information about your data, but frequencies is also going to give us a list of all the values of our data and tell us how many cases fall into each one of those values. So for right now, let's go ahead and use frequencies. When I click on frequencies, I get a pop-up dialog box that allows me to select any of the variables that are over here on the left-hand side. These are the same variables in the data set. So what we want to do is we want to go down and let's find defendant's gender, and it happens to be right here. If I highlight over it, it should pop up and tell me defendant's gender, mon-sex, once again, which is the variable we are looking for. Now keep in mind, if you would rather list the variable names in here rather than the variable labels, you can always go to Edit, Options, and then check the Display Names under Variable Lists rather than Display Labels. So that's an option that you can select if you want. For now, I'm going to go with the default options, which is to display the value or the variable labels. So I'm going to click on defendant's gender and I'm going to pull it over. Clicking the arrow will bring it over. You can also double click on a variable and it'll drop it in too. So after I've brought defendant's gender over here, I could click OK, and this will essentially give me a pop-up. Once again, over here is the syntax. So this is the underlying computer language that the computer's running when I'm doing these click and play menus. So that's the computer language. If you're familiar, want to know, want to kind of get comfortable with that. But if we go down to this output, we can examine how many cases there are of this variable. So in the data set, we can see that there's 71,000 cases that are valid, and that means there is a value there for it. And there are 1,571 cases that are missing. This means we don't have this information for this variable, so they've been excluded from our analysis. So we can go down here and examine that males in this data set constitute about 61,000 individual cases, and females constitute about 9,000 individual cases. This is approximately, once again, with a sample size of 71. Now notice how it lists system missing here below. Those are the same cases that are missing here. So that goes ahead and kicks them out above that. So we have male, female, and then the total number of individuals. Total number is 71,000, 71,000 up here. So we can go over to this valid percent, and it'll tell us out of 100%, the entire distribution of values we have. 13.3% are female, 86.7% are male. Now we also have this percent here, which is out of all cases. Notice this is the total cases 100% with 2.2% of our sample missing because it doesn't have a gender value. That means there's 97.8% of the cases that do, and 13.1 female, 84.8 male. So once again, the difference between the percent and the valid percent is that the percent basically accommodates for, incorporates the missing data. The valid percent just excludes the missing data. So it's only out of the cases that you have. So let's examine another variable in here. So I'm going to go ahead and close this. It's going to ask me, are you sure you want to close this? And I'm going to say yes. I'm going to go back up to Analyze, go to Descriptive Statistics, slide over to Frequencies, and go back to this dialog. Now I have defendant's gender in here. I am going to double click it, or you could click this button and put it back over to the side. And let's get a different variable to examine. I'm going to go down to education. Now, once again, we have education in here as an ordinal variable. So I'm going to click it, bring it over, and we're just going to click OK. Now notice how this checkbox has display frequency tables. That's what's giving us this information. So I'm going to click OK once again, and we're going to get another table. Now in this situation, we have 6,500 cases where we do not have information on the defendant's education level. 66,000 cases approximately that we do. So it's the same deal that we had for gender, just with a different variable in this case. For education, we have less than high school graduate, some college, and college graduate. So once again, we have the frequency of all the cases in here, all of those categories totaled, plus the 65,000 missing, for a total of 72,585 cases. Remember, the percent will give us the breakdown of these percentages, incorporating the missing cases in here, and this is a substantial chunk, 9%. And then the valid percent gives us the percentage of cases excluding the missing variables. So in this case, out of all cases we have a value for on education, we see 48.7% of individuals had less than a high school education, 30.1 had a high school graduate degree, or a high school degree, 15.5 had completed some college, and 5.7 individuals in this data set had a college degree. Okay, so once again, we could look over at the raw frequencies and things of that nature. Now, one of the reasons I wanted to bring up this variable in particular is because we can talk about cumulative percent. So in this case, we have education in order, right? We're going from less than high school all the way up to college graduate, and they are in that physical order. So the top value here is the least amount of education. The bottom value is the highest amount of education. What cumulative percent does is it adds up the percentage, only the valid percent, as we go across the categories. So in this case, once again, the cumulative percent at less than high school is 48.7%, exactly how many people had a less than high school education. But if we go down in the cumulative percent to the next level, this tells us the percentage of individuals who had either a high school degree or less than high school, 78.8%. And if we add these two values up, 48.7% and 30.1%, we would get that amount. So cumulative allows you to add up as you go. And this is very helpful if you have a lot of information. So I'm going to close out of this, and now I'm going to go to one last example, number of months in prison. So I'm going to go frequencies, move this back over again, and I want to go get that variable that's the number of months someone spent in prison. And I'm going to bring that over. I'm going to click OK. This chart is going to be huge. The key here is that there's so many cases and there's so many potential values for individuals sentenced to prison. So in this situation, we have a little over 72,000 individual valid cases, only 528 cases that are missing in here. That's phenomenal. And we can look over here. So this is the number of months someone was sentenced to prison. In this case, we have 0, about 13.6 thousand individuals, 18.7% of our sample in whole. We're not sentenced to any prison, and this makes sense from a criminal justice standpoint, doesn't it? A large chunk of people are getting deferred sentences or being sent to some type of community sanction where they're not spending any time in prison. So if we scroll down, we can examine all of these distributions of the number of people for each one of these categories. Now we keep going down, notice that we get a lot of clumping on particular values, 60 months, 70 months. These are values that judges, kind of round values that judges are going to distribute. And as we get higher and higher, we're going to see that they're clumping around particular special values within the data set. But we keep going. This is going to give us all of the values within this variable. And we see that the highest or the longest sentenced individual in this data set was 3,781 months. This might be a little bit of overkill sentencing wise, because realistically, if you figure a person lives to 100 and was sentenced when they were born, I guess 12 months times 100 would be 1,200 months. So this person's going to live approximately 3 times someone's typical life. Perhaps excessive sentences out here, but there are political reasons as to why those sentences might have been handed down. So when we look at this entire distribution, we can see this is a situation where cumulative percent would be really handy. If we wanted to know the percentage of people who were sentenced under 72 months, we could slide down and find 72 months on our distribution, and then come over here to the cumulative percent, and we have 79.3%. This means 79.3% of our sample had a sentence of 72 months or less. So this is a situation where the cumulative percentage can really save you a lot of time instead of having to add up all of these values as we go. All right, so now we should feel comfortable about examining the distribution here, examining the frequency tables. And once again, in order to get those, you need to check this box right here. So if you want the frequency table, make sure you're checking that. If you do not, you can uncheck it. So for example, if I'm running some other statistics on number of months, I don't want that huge table to come up again, I could just uncheck that box and it won't pop up. So now that we've talked about, we have a good feeling about how to kind of examine frequency tables, I want to talk about univariate statistics. These are pieces of information essentially that summarize essentially what the value is or what the distribution of values are within a particular variable. Univariate statistics, are oftentimes referred to as descriptive statistics, are extremely important because we want to know what your typical case looks like, and we want to know what the spread of cases are. Remember, this is the difference between measures of central tendency and measures of variation or dispersion are two common names that they go by. So let's use number of months because it's really critical that we have a ratio or interval level variable. I'll often just refer to them as metric for all intents and purposes, kind of merging them into one. So let's use number of months as one of our variables to examine for this because we can do a variety of things with it. Now, before we just brought the variable over, clicked OK, and examine the frequency table. However, there's more information that you can get. If I go over here, there are buttons on the right hand side which allow me to request additional information. So if we start at statistics and click that button, we'll get a dialog box that gives us all sorts of menu options about what type of statistics we want. Now there are measures of central tendency. And remember, the mean is the average value of the case within that variable. The median is the dead center value within that, and that's all cases lined up. So what's your center value within that distribution? And the mode is the most commonly reoccurring value within that distribution. So for number of months, if we want to ask the question, what is the average number of months, or what does that center case, that typical case look like within this distribution, we can go ahead and check mean, median, and mode. Now, obviously, you would want to select the one that is best for you and best for your data. I'm going to request all three simply as a description. There are also measures of dispersion here. Once again, dispersion, measures of variation. There are some different names for it. But this examines the spread, how broad, how far out, pushed out your distribution is, how far cases are from the average case, what the spread looks like. So we have a variety of options we can request here. We have standard deviation, variance. We can get a range. We can ask for the minimum or the maximum value or the standard error of the mean. In this situation, let's request a little bit more than we would typically have to do. Let's get standard deviation, range, min, and max. There are also other things if you want to know quartiles, so values that fall over, under, or at 25%, or you could cut into particular percentage points. You could bring that into the percentage values. And if you wanted to know the skewness or kurtosis, essentially how bent your distribution is, you could request those values as well. But I'm going to stick with central tendency and dispersion, and I'm going to click continue. So that's logged in here. It's good to go. So when I click OK, it will run the information for me, and it will give me that information back. And so we go down here. Here's our distribution frequency table. It is huge. It takes up so much room. And at the end of the day, we already examined this. So what I'm going to do is, over here on the left-hand side, we can see that if we click on this, it's going to highlight the number of months table. I am just going to hit delete and delete it out of there. We don't need it at this point in time. We can always request it later if we want to, but this makes it nice and easy. Another way, if you didn't want to have it in the first place, is we could have requested that information, remember, by unchecking this box. Had we unchecked that box, we never would have got that huge table to begin with. All right, so let's examine the descriptive statistics for the number of months these defendants were sentenced to. And keep in mind, this data has been manipulated slightly to make the examples easier, as well as this is a small section, essentially, of all the federal sentences that were handed down. So this is not necessarily descriptive of all the federal sentencing data set. However, out of our sample, so we have 72,057 cases. 523 of those are missing a sentence or a number of months variable value, essentially. So those are kicked out. So the average, the mean sentence, the average sentence that an individual received in this data set is about 50 months, 49.93 months. The median, or the value in the center, and keep in mind, so this is lining up all of the individual people, all the individual cases in this situation. So you have all the defendants in a line, and you find the exact dead center person. What was that individual person's value? In this case, that person received 30 months. So that tells us where the center case is, and can give us a different measure or a different feeling about what that typical case looks like. Now, the mode in this situation is not very helpful because at the end of the day, it was 0. Remember, we had 18+% of individuals who did not receive a sentence from the judge, deferred sentences, things of that nature, community release. So in those situations, these individuals received nothing, and so in this particular case, mode might not be very helpful for us. We know now that, yes, that's the most typical sentence that's handed down, but it doesn't tell us the center of our distribution or the average. So once again, any of these statistics telling us the measure of central tendency, you need to be careful about which item, which one you are using for your particular data set. So think, what do you want to know? Do you want to know the average value? Do you want to know the center value? Or do you want to know the most common value within this variable? So if we examine the last four here, we have measures of variation or dispersion. Remember, the standard deviation is the average amount of spread, essentially, that a case has. So on average, how much do your cases deviate? Here we have a value of 75.784 if you're going all the way on the decimals. This tells us, now notice how your standard deviation is actually larger than your mean. What this tells us is that we have some really massive spread in our data. Our cases are way out there, so there might be a whole lot of very low values, or there might be a whole lot of very high values. My guess would be in this data set, and remember we had some of those. If we look further down, we can see the range of sentences. So we have 3,781 months in the range from the smallest to the highest value within this variable. And we can look and confirm that. The minimum is 0, those people who got kind of deferred sentences, and the maximum sentence handed down was 3,781 months. So we can get a feeling. Think about it. Your highest individual in this data set is 3,781 months. When that person is calculated in the average of these sentences, that's going to pull that average way up. Remember, the mean is very sensitive to these outliers, which are going to statistically pull it out. Pull that mean or inflate that mean. And we can see that once again because our mean is higher than the median. Hence, the average number of months is to the right or higher than the center case within the distribution. So it is possible that we might want to think about using the median to describe the average case within this data set. So there's a discussion that can be had there. However, at this point, we should feel comfortable about descriptive statistics, both central tendency and variation dispersion statistics. And we should know how to run them. We should be comfortable within that regard. All right. So now let's look at crosstabs. Crosstabs are a really neat tool because we can actually overlap two individual variables essentially to see how they mix, how they change with respect to one another. So I'm going to start off with a very nice simple example. I'm going to basically ask the question of, I want to know what the comparison between education and gender is. Essentially between men and women on the gender side, and then those 4 levels of education, I want to know what the distribution is. Are men generally more educated within this data set? Are women more educated? Are they essentially the same? Is there really no difference between the two? So in order to run this, in order to compare these two variables, we're still going to go to Analyze. We're going to go down to Descriptive Statistics, but instead of going to frequencies, we're going to go down to crosstabs. And when I click on this, it's going to do the same thing. It's going to give me a menu selection of the variables on the left-hand side, but instead of having one column over here, it's going to have rows and columns. And what this is going to do is it's going to allow me to say which variable goes into which one is set up on the columns, which run up and down, and which one are in the rows, which go from left to right. So in this example, I'm just going to kind of randomly pick, let's go ahead and put gender in the rows. So I'm going to go down here and find defendant's gender once again. If I hold over it, I'll see defendant's gender, Monsex. That's exactly it. So I'm going to pull that into row. And then I'm going to go down and find education ordinal and pull that into the columns. So when I ask this, when I run this essentially, and let's just go ahead and do that, we get exactly this. We get a little bit of information essentially about the valid cases in here. Essentially, what cases did we have overlap? In this situation, we had approximately 66,000 cases, or about 91% of the entire data set that was usable. It had information on both gender and on education. However, we were missing about 6,500 cases, the other 9% of the data set, for the total of the data set, once again, 72,585 cases, or 100%. So if we look down here at the bottom, this gives us the distribution. This tells us how many cases are in each one of those. So we can see for males, as it goes along the edge here, we can see how many males had less than high school education, about 29,000. How many had a high school education, about 16, almost 17,000. Some college, about a little over 8,000. And graduated college, 3,162 individuals, for a total of 57,246 males within this subset of individuals having both categories, education and gender. For females, we can see the same information, but notice there are a lot, the numbers are much fewer for women. And in this situation, we actually only have 8,800 or 8,807 women who have both data on gender and on education. So, and once again, our totals, so add up men and women in here, match 66,053 cases right there. Now the question becomes, well, can we get more information on this? Can we get percentages? Yes, we can. What we're going to do is we're going to rerun this. So I'm going to close the window and let's get our dialog box back up. Once again, Analyze, Descriptive Statistics, go down to Cross Tabs and click on that. So we can leave the row and the columns here, but we're going to go over to the right-hand side and we're going to click on Cells. When we do that, it's going to give us a variety of options that we can examine. Some of these aren't going to make a whole lot of sense until we talk about some of the statistical tools that we can use, some of the inferential statistics, things of that nature. However, what I want to look at right now are the percentages. Notice we have an option for row, column, and total. So this gives you the percentage by whether by the row or by the column. I always get this personally mixed up, I'll admit it. So sometimes I have to click one, run it, and go, that's not what I want, and then go back, click the other one. The easiest way to remember it, though, in my mind, is if you ask for rows, it will make everything out of 100% on that row. If you're asking for columns, everything will be out of 100% on that column. Let me show you what I mean. So I'm going to check rows here. And remember, rows, I'm going to click continue, are associated with defendant's gender, male or female. So this is going to make everything, it's going to tell me 100% of the men and 100% of the women. So we can examine what percentage of men had such and such education level. Let's run this and see. So when we do, it's the same thing. However, we have this additional kind of little row here that examines, it tells me what the percentage. And look over here, right? So out of all the men, we have 100% of the men. So we're examining fully just the male and just the female categories, and we're comparing between educational levels. So for all men, once again, we're requesting on rows. So we're interested in examining gender and how the breakdown of education goes. So for men, 50% of men had less than a high school education. Women had 36% who had less than a high school education. When we move up to high school graduate, we see almost 30% of men had a high school education. 32% of women had a high school education. When we come up here, we have some college. We have 24% of women, 14% of men, and at the end of the day, college graduates, 5.5% of men and 6.6% of women. Perhaps we've solved the age-old question of who is smarter, men or women. When it really comes down to it, the key here is if we request about rows, we request percentages by rows, that means we want to examine rows and we want to be able to compare the row categories. Now let's rerun this using the other column. So we go to Analyze, Descriptives, Analyze, Descriptive Statistics, cross tabs. I'm going to go over here once again to the cells, and I'm going to uncheck row and get column. And what this is going to do now, and we see it's shifted now. Now we have 100% of high school, 100% less than high school, 100% high school, 100% college, 100% college graduate. So now we can compare out of all of the high school, less than high school graduates, 90% of them were men, almost 10% were women. So notice if I'm interested in just examining the education level, then we want the columns here to make the comparisons between. So once again, if you're not getting the information, you're not getting the percentage you want, flip it. Move from column to row or row to column. Now there's one other option I do want to very briefly demonstrate to you, and that is the total. So we're going to bring up our cross tabs again. We're going to go back into cells, and I'm going to uncheck column and check total. If I run it this way, it simply gives me the percentage for each one of those cells. In this situation, it gives me the percentage of cases for these particular cells. So if you add up all of the cells, you will get 100%. So total is taking the percentage out of the entire data set. So in this case, we have women who were college graduates. We had 577 out of the data set, and we had 66,053 cases within the whole data set that met this criteria. So if we take 577 and divide it by 66,053, we will get 0.9%. So once again, you add up all of these cells, you will get 100%. For all intents and purposes, you're not going to use total a whole lot. You're typically going to use rows or columns. So one last thing I kind of want to demonstrate, and that's what not to do with crosstabs. Now keep in mind there are better tools to examine metric level variables, the ratio or interval level variables, but I want to show you how nasty it can get if you accidentally drop one in. So we're going to go back into the crosstab, and let's say we don't want to know anything about educational level, we want to know about number of months. So we're going to go down, pull that number of months variable in. Let's just get rid of the percentages because let's just not bother with it for right now, and let's click OK. This is a nasty table, because there are so many categories of number of months. Look at this. If we slide over, there has to be now a new column for each value of the months. So you do not want to request this information on metric variables, the ratio or interval level variables. There are other tools that we can do to kind of compare, and we'll talk about those at a later date. So once again, we've covered basic descriptive statistics within SPSS 23. We should have a good feeling of how to run univariate statistics. Once again, central tendency, mean, median, mode, variance, and dispersion. So those measures of variance and dispersion to see what the spread is of our data. We also understand how to run crosstabs now to compare two categorical variables. Nominal or ordinal typically is really what you want to be examining. One very last quick thing. If we're going back to the univariate statistics looking using the frequency menu, this is another reason to use frequencies over descriptives. Descriptives, if you want to use it, is just going to allow you to request particular statistics. However, if you use the analyze, descriptive, and frequencies, which we've been using, and once again, we still have the number of months in here. I'm going to take away all of those statistics that we had in there earlier because I want to show you one very quick thing about making a chart. So we can click on the button called Charts, and it will give us the option to request a bar, a pie, or a histogram. Now in this situation, we want to request a histogram because we have data here in this point in time where it can skip intervals, so bar chart's not going to help us out. We don't want a pie graph, at least not in this situation. Let's request a histogram and click Continue. We click OK. Here we go. So this actually maps out our data for us and displays it in a chart form. So this gives us a visual representation of exactly what that data looks like. I'll give you another example. Let's find another one. And in this situation, let's request something such as gender. So what we can do is we can bring in the defendant's gender, and we can do the same thing, charts. In this case, we want bar charts because they're not continuous values, and run a bar chart. And this will give us a quick visualization of what our data looks like. Hopefully this has helped. I'll have more videos coming up to try and examine some other functionality within SPSS. Otherwise, if you have questions, please let me know. Have a good one.